potential dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hello, contributors. How are you? Today I'm here next to my colleague, Victor Sanchez. Hello, Victor.
Hey, Andreu, how are you? Thank you for having me again.
Nah, this is not having you. This is more a question of the lovely Liquid Galaxy project community. And you today are here not as only a colleague, but as a friend and also a mentor for many years on the projects we do with the different contributors, students from around the world. So today we are going to talk a little bit about the Gemini Summer of Code contest that we did. It's something like GSoC, but instead of Google, it was Gemini because we are on the crazy year, because it's a crazy year of the agentic AI. Is that right?
Absolutely right. I mean, we gave the students, right, this year something very different. And is if you remember, we had a very cool, I think it was a very cool session where I showed them my setup to create web applications for the Liquids Galaxy, right, through agent. And we saw actually three things, right? The agents, of course, Gravity, right, the Google Antigravity IDE. And we saw a little bit of the skills that I made based on the very best projects. And that's the beauty of open source, right? That we were basing these agents in the very best projects of prior years. And we gave the students a challenge. Do you understand enough of agents? Do you understand enough of the Liquid Galaxy? And are you able to reuse all of this beautiful knowledge that we have accumulated over the years? And probably not in 3 minutes. That's something that I only can do for now. So probably I have to say, they put a lot of effort here, Andrea. There is some impressive projects. So yeah, I'm very happy of the results. But it kind of showcases, right? With proper guidance, AI can be yet another tool to build incredible things. And I think as well to build incredible understanding, because as you know, these agents, the way that we have configured for the Liquid Galaxy, yes, they will help you create impressive applications, but they won't let you advance unless you understand what you are doing. And I think that mix is pretty cool.
That's the pretty question, that it's not only just a matter of using the AI, but you have to understand, because if not, it has no sense. So we get something like 15, if I don't remember well, 15 contributions to the Gemini Summer of Code contest.
14, 15 contributions, most of them on the Flutter side, because obviously trying to do web was very hard. They had to match me. So it was a hard one. I'm sorry. I told them it would be hard, okay, to the web. But no, I've been impressed, because again, one of the things that they had to do, right, in order to teach these agents the best practices on how to do Flutter applications for the Liquid Galaxy, they had to go back in time to the best projects of the community from many years ago, right? And you clearly saw, and we're going to try to not put spoilers here, but you clearly saw that the very best projects are those that had the very best data, because they picked very well very good previous Flutter applications. And that was one of the key insights on how do you win this thing. It was, great agents are only great if they have great data as context. And some of these guys,
it's a matter like the training. Like the training, if you don't have good data, you cannot make the training.
So important.
So we get these entries to the contest. Very nice. We make a selection. I want to say it, at least for a few seconds. I think you have help from some artificial intelligence also. At some moment, it was not the final decision. The final decision
No, the
was
final decision
ours.
is very human. I
It's
chose
totally
it and I
human.
suffered through it. But yes, one of the things that I made is I created a number of skills that were going to analyze a bunch of different stuff. So all of the base code was analyzed by Victoria. All of the agents were analyzed by Victoria, and I did something really cool. I had my agent speak with theirs. So I loaded their skills and I interrogated them about Flutter best practices. Because why not? You know, I mean,
That's the crazy here with living, Victor. If nobody
I had
understands
to
what
do
I'm
it. It was
asking,
so cool.
it's normal.
Yeah.
So also we have to devote 10 seconds to say who's Victoria.
Oh yes, Victoria is Victor AI, right? So she's my AI. Is my personal assistant, my open claw that now is no longer an open claw. She started as an open claw, now it's her own
It's
thing.
his own open cloud version.
Exactly. My own agent version at this point, right?
Yeah, exactly.
And she helps me with many things. This was one of them. But I have to say, she basically gave me like half of the list where, these half of them are so strong that I cannot decide, you know? And it's like, fucking AI, you know, absolutely useless. I'm sorry for my friends.
Don't say that.
Sorry.
Okay, so thank you. First of all, thank you, Victor, very much for your help here. I'm pretty sure contributors have learned a lot from the sessions you did and also from the Gemini Summer of Code contest. And contributors, as you remember, we are not going to present today who are the winners or the winner, we can say.
Not yet.
Because that's a secret till the day that Google makes the announcement of what project has been selected for GSoC this year. But we are going to show after those words, we are going to show all the videos the different contributors sent to introduce their projects. This way it's open for the community and we all can learn and share thoughts about.
Also, if you let me say something, especially the top 4, it was horrible, Andrea. I have to tell you, you know, the top 4, the last 4 that I was going to decide with, I wish I had.
No, when you say it's horrible, you mean that you have a hard decision to take.
I suffered. It was so hard.
You suffered because they
were so good. Honestly, the first 4, I wish I had, you know, more golden tickets to give that only one. Because the first 4 really did an amazing job, really understood the task. There is a lot to be proud in here. And yeah, I'm super looking forward, you know, to discuss who is the winner and who this kind of top 4 were.
And also you say we are looking forward. We are all looking forward because we don't know how the Google Summer of Code, not the Gemini, is going to go. Because of the use of AI, we are trying hard to be on a right way, but nobody knows exactly what is that. But at least we are having. We hopefully will have some contributors working on projects where the agentic AI with Google's Antigravity and so on tools will be very important. And maybe we draw the path for the future on doing the applications not only for our community, but also for the contributors to learn how to this industry is going this crazy 2026.
Again, I'm learning all the time as well, you know, and some of the things that we taught in the session that was less than a month ago, some of those things are not true anymore. You know, you have to update at this pace. So yes, AI does a lot for you, but the truth is that unless you are right there, ready to learn the next thing, you are going to be left behind even in the age of AI. So I think learning to learn becomes the most important thing. And I think that's exactly what we do at Google Summer of Code.
Perfect. Thank you, Victor.
My pleasure.
And now, contributors, let's see the presentations from the other contributors to the contest Gemini Summer of Code at the Liquid Galaxy project for this Google Summer of Code 2026. Take care. Bye.
See you now.
Hello, Liquid Galaxy team. My name is Antigravity, and this is my submission for the Gemini Summer of Code contest. In this video, I'll walk you through the Flutter Starter Kit that I have created, and then we'll build a live LG app, which then we will test it out on the Liquid Galaxy rig. So let's move on to the screen. So the goal of this Flutter Starter Kit is not to provide a full application, but rather than a basic backbone or the skeleton of building an Liquid Galaxy app. So whenever a new user wants to create a Liquid Galaxy app, a new contributor wants to create a new Liquid Galaxy app, they can just clone this repo, and the basic skeleton will be in their hands, and with the basic functionalities that an LG app needs, like relaunching, shutting down, sending logo, sending a KML, clearing KML, etc. So let me show you how this app looks, how the Flutter Starter Kit looks when you run it on an emulator. So this is the home screen. It says that connect to the LG via settings, LG rig, then build your feature in this area. So we'll go to the open LG settings. Here are the credentials for my rig. So I'll just click on the connect button. As you can see, it is connected successfully and the red dot has turned green. So we can, in the bottom navigation bar, you can see there are basic features like shutdown, relaunch, clear, and send logo. So if I click on the send logo button, the logo is sent to the left slave. As you can see, the logo is appeared. And if I click on the clear button, all the KMLs are logos are cleared. So this is the basic skeleton, and this is the basic skeleton and the Flutter Starter Kit. When a new contributor clones the repository, they get this. So let's now let me walk you through the code base of the starter kit. So firstly, this is the .agent folder where all the skills and the workflows are present. So these are the skills that are present that the AI agent uses for context and follows these. So the first one is the architecture guide. So this is the secret weapon, enforces that generated code follows the starter kit architecture. So basically the project architecture is described here. So every Liquid Galaxy app uses this basic architecture, and this skill instructs the agent to follow that architecture. Then we have the brainstormer, which generates well-scoped technical feasible app ideas and how the app would be implemented and the architecture of the app. So this is the brainstormer. Then the code reviewer, which reviews the generated Flutter code for quality and LG compatibility, etc. Then this is the LG initiation, verifies that the project is correctly set up before any code generation begins. Then we have the KML builder, defines exactly how to generate valid, safe, LG compatible KML in Flutter. So all the fly into a location KML or the KMLs are generated as per the user's prompt. Then this is the network link, which is used to show the KML or display the KML on the LG rig, because the KMLs on the LG rig are displayed using the network link. And this is the plan writer, which is referred by the agent when the user has an idea for an app. So how that app would be executed, what are the steps, that all is planned by the plan writer. Then this is the skeptical mentor. This is the mentor that checks, that is running behind, which is checking if all the things are working fine. And the final quality gate. This is the final quality gate, refuses vague claims of completion and demands hard proof. So this is the skeptical mentor. And then we come to the workflows. So this is the workflow. So run this workflow. After initial code generation, it systematically finds and fixes quality issues before submission. So this is the workflow. Then we have the lib folder, which contains the constants. So this is the app constants, which are used mostly by every LG app. Then we have the controllers. This is for connecting with the LG rig, SSH controller, settings controller to store the IP address, port, etc. So that the user does not have to write it again and again, input it. And this is the LG controller, which has the basic functions like you saw in the bottom navigation bar of the app starter kit. And then we have the views folder, which has the home screen and the settings screen. So basically the UI is in the views folder. And this is a test folder, basically a test, a basic tests are run before working on this repo. You can just run these tests, and if all the tests are passed, the code is fine. So this was the okay, we are missing agents. Yeah, Gemini.md. So this is the file that is in the root of the project. So whenever Antigravity is launched, the AI agent refers to the Gemini MD, which has some instructions given to the agent. So then basically Gemini MD is used for telling the anti-gravity agent that as soon as you're launched, whatever prompt that the user is giving in the agent, refer to the .agent folder from the start. Don't use your own brain, use your own brain, but for the context, refer to the .agent folder. So this is where the Gemini.md folder is used. So yeah, basically this was the Flutter starter kit for the Liquid Galaxy. And now we'll move on to building an LG app live, which is basically a LG City Explorer called LG City Explorer, where we'll use the Wikipedia API, and whenever a user searches for a city, then an information card of the city is shown on the app, which is extracted from the Wikipedia API, and then the user also flies to that location using the fly to command on the LG rig. So let's start building the app. Yes, so now I have cloned my own repo in my local, and let's start building the app. So this is the prompt that I'm going to give. Build me a Flutter app called LG City Explorer as a new repository on top of the starter kit. One second. This is a new repository, so we'll just skip this. Yep. The app works like this. User types the city name. App calls the API, Wikipedia REST API. API returns title, extract, latitude, longitude, thumbnail. Flutter UI displays city name, Wikipedia summary, thumbnail image. App builds a KML placemark at the city coordinates with the city name as the label and a pin icon. KML is sent to the LG, and the camera flies to that city using the fly to query. The left slave screen shows a KML screen overlay with the LG logo at the top, the city name in large text below it, 2-3 line except from the Wikipedia below that. Okay, user can tap clear to remove all KMLs. If the API fails or city is not found, show a friendly error messages. Proceed one phase at a time and wait for my approval at each phase before moving forward. So this is the prompt that I'm going to give to build the LG City Explorer. Yes, so I'll be giving this prompt. So let's hit the send button. It will generate. Let's wait for it. Initiating project understanding, thinking. It should refer to the agent folder and the skills. Okay, as you can see, has analyzed the skill.md files and it has analyzed the .agent skills. Okay, so the phase 1 of the LG init, it referred to the LG init skill. So I'm sorry if you can hear any background noise. There's a festival going on in my local area. So let's move back to the Flutter Starter kit and let's run this command that it is asking me to run this one too, and then run this one too. Okay, so first it referred to the LG init skill.md file. To start with the app creation and generating code because before generating the code it has to go through the LG init skill, the agent. This will take some time. Completed phase 1, waiting for the user approval to proceed to phase 2. Okay, it has started changing. Okay, it has changed readme.p, ready to proceed to phase 2. Shall I generate the project brief? Phase 2 would be generating the project implementation plan and the tasks. So I'll just say yes, you can proceed to phase 2. So in the LG init, it added the dependency structure is okay. It checked the structure dependencies, SSH contact is fine, and the persistence is also fine. Okay, so as you can see, it has created the project brief for the app. So the LG brainstormer past brief generated. I've created the project brief for domain features, what features, the domain, the scope, ready to proceed to phase 3, which is the plan writer, which will create the whole implementation plan and the tasks, how we are going to build the app step by step. So yeah, looks good to me. Yes, you can proceed. You can proceed to phase 3. So as you can see, after performing all the phases, it asks for the user to proceed and also gives a brief on what it did in the previous phase, a brief summary. So that is good that the user has the control. So it has created the implementation plan of the LG City Explorer app. So as you can see, the implementation plan has a feature list, the project structure, data flow, SSH command plan, everything is created and referred with the LG plan writer. So as you can see, the brief is given, defined standard to slave and slave to usage, city controller. Okay. So implementation plan is done. Shall I proceed to LG architecture guide to audit this plan? Yes, you can proceed. Everything looks good till now. Okay, so it is done with the LG architecture guard, the phase 4. I have audited the plan against the 6 strict architecture rules. MVC separation, models are pure, view logic is separated, controller handles business logic, provider using change notifier provider. Okay, SSH all commands route through SSH controller. KML all string building is delegated to KML helper. Settings, inheritance. Okay, looks good, everything looks good. Let's move to phase 5. The plan is compliant. I am ready to start the phase 5 implementation. I will generate the code file by file, starting with city model. Okay, so here comes the part where the agent starts coding. Okay, so it has edited the city model. This model passes the Wikipedia API response. Okay, so this file is used to pass the Wikipedia information and to the UI. Okay, so yes, accept all. So now it is editing the app constants file to add some constants, I guess, to the existing code. Let's see what it does. Okay, it has edited the app constants, analyzed the KML, updated. So the Wikipedia base URL, it has updated. Okay. So I'll accept this. Yes. Ready to proceed to KML helpers. So now it's going to look into the KML helper file, which has all the KMLs, all the fly to commands, the LG logo, etc. Everything is written in the KML helper file. Okay, so it has edited the KML helper.dart file, updated the KML helper with build city placemark, generates KML for the city marker. Okay, build city overlay generates KML for the slave screen logo overlay and text balloon. Note KML cannot display dynamic text, so I used transparent balloon element for the text portion. Oh, nice. Okay, so I'll accept this. Yes. Proceed. So it has updated the KML helper. Yes, this is what it has done here. The KML helper, and also in the models, the city model, which extracts the information from the Wikipedia REST API. Okay, so now it is starting the phase 5 implementation, which is mainly the controllers, which has the main functions. So it has edited, it is generating, let it generate. Enhancing LG controller with generic slaves KML support, except fixing KML helper limit and creating city controller. Okay. So it has created the city controller.dart file, which I suppose has the all app function, main app functions in the backend, which the UI just calls it. So this is the main .dart file is also updated so that it loads the home screen accordingly. Created city controller and wired it in main.dart. Fixed linked KML helper, ready to proceed to views. Okay, so now it is going to work on the UI of the app. So yes. Now the UI UX of the app will be created, I guess. City info card, yes. So implemented controllers and wired city controller. Now fixing a lint in KML, implementing, removed. Okay, let it work. KML helper, okay. Okay, so the home page is also done. Implemented home page and city info card. UI features, search bar for city name, fly to city button with loading state, clear button, result area displaying, city info card, title, summary image, quads, connection dot. Architecture is fully implemented, ready to proceed to phase 6 LG code review. So now the code reviewer will review the code, and if there are any issues, it will rectify that. So it has analyzed the KML helper test file. Okay, so running code review, identified missing tests. Now writing test models. Achha, so it is writing a city model test. The city model to the city model file, which was used to fetch the information from the Wikipedia REST API. So it is testing. Run test. Run the test. Accept. Waiting for further test results. The test results are bad. All tests passed. Okay, this is good. Home page. Yep. Accept this. Okay, the LG code review passed. I have run the code review and validated the following: try solid, no significant valuation, naming, okay, error handling, uses try catch with user feedback, okay, test passed for the city model.dart file. I am ready for the final gate, phase 7. Shall I proceed to generate the proof of work? Yes. So now the skeptical mentor will come into the picture. So enter the phase 7, generating strict proof of work, including test results, KML samples, and verification steps. Generating proof of work, analyzed readme.md. Okay, so the proof of work is done. SSH connection proof, KML content proof, slave KML, LG deliverable, delivery proof, visible on screen proof. Everything is done. The LG city, so I have generated the proof of work, SSH KML delivery test. The LG city explorer is ready. Search, homepage, city controller, Wikipedia. This is the flow of the app. And okay, so the app is done. Wow, that was fast. Under 10 minutes it was done, I guess. So let's try it by running it on the emulator. So the emulator is on Flutter run. Let's see. Fingers crossed. So the app is loaded in the emulator. Let's open it. Okay, this is what it has created. A settings to connect to the LG rig. You can type a city's name here, clear the KMLs, fly to the city. Okay, that's a good app. That's a good app created by the, if it is created by AI, a good start and a good start to the contributor. It gives a good start to the contributor as well. So yeah, so I guess it's time to test it on the Liquid Galaxy rig. So let's test the app. Okay, so my LG rig is up and running. So let's test the app on the LG rig. So we'll go to the settings page. This is the same IP. So let's click on the connect button. Okay, so it has connected to the LG rig. Let's type in my name, my city name, I guess, Pune, and fly to the city. Okay, as you can see, the card is generated with the latitudes and the longitudes and the brief summary of the city with the LG logo on the left rig and a KML right here. As you can see, the KML is here. If I move it here, okay, so if I click on the marker, so it has a brief summary card of the Pune directions, which it has fetched from the Wikipedia API. Okay, so this is excellent, I guess. Creating the KML, then creating a balloon, creating this card, it's excellent. So if I click on the all clear KML, all the KMLs are cleared. Okay, so this was the demo video for the Gemini Summer of Code contest and the Flutter starter kit that I have created. I thank the Liquid Galaxy team for their time and consideration, and I hope this starter kit and the workflow system can contribute to the Liquid Galaxy ecosystem and support the future GSoC projects. Thank you.
Hello everyone, my name is Aryan Sharma and this is my submission for Liquid Galaxy GSoC 2026 AI contest Gemini Summer of Code. Today I am going to walk through you everything I built, a complete Flutter starter kit for Liquid Galaxy powered by an agentic AI system using Google Antigravity and Gemini. The goal of this project is simple. Instead of building just one app, I built a system, a system that teach AI how to build Liquid Galaxy Flutter app correctly every single time. By end of this video, you will see the starter kit and how it is structured, the agent skill that act as the AI brain, and a real app demo that was built using the exact system. So let's start first. You can see this is my GitHub. I have two repository, LG Flutter Starter Kit and Gemini Summer of Code. The first one is the LG Flutter Starter Kit. My main submission is this uh, GitHub Gemini Summer of Code. It contains the Flutter template app and the .agent folder, which is the AI brain. The second repository, this LG Flutter Starter Kit, is the app demo that is made by this AI brain. This is the demo application built by the agentic system I created. Let's start with the go through the GitHub. This is the main GitHub repository submission. Let's start with the I have lib folder. You can see inside this lib folder we have a fully working template of the Flutter app. We have core folder, model, provider, screen, service, widgets, and the main.dart file. Main.dart file is the entry point. Services folder has LG connection service and API service. The screens have two screen, home screen and setting screen. Models include the KML model and LG data model, and the, these have the themes. These are and the widget have the reusable widgets. These are the files that we have inside the lib folder. When someone download the starter kit and run flutter pub get followed by flutter run, the app work immediately. It connects to Liquid Galaxy, fetches data from an external API. I have used weather API for now in this app, and it convert the data into KML and send it to Liquid Galaxy screen. But the real magic is not here. The real things is inside this .agent folder. Let me go through this now. Inside this agent, we have the rules.md and skills. First, we have inside agent folder, you can see the skills directly. This is where I have written detailed instructions for the AI. Things of these file like a training manual. When Google Antigravity read these files, it learns how to write code for Liquid Galaxy app. It learns the pattern, the basic practice which Liquid Galaxy apps generally use, the library to use every time, the main libraries. I have added the five skills. First is API integration, Flutter UI, KML generation, LG connection, and the state management. Yes. Now let's start with the main thing, that is our connection with the LG rig. So let's come to Liquid Galaxy connection skills. This is the connection skill. The first is connection .md. This is file extension is .md. This file teaches the AI. Let me show you the codes. Then let's the this file teaches the AI everything about connecting to Liquid Galaxy rig over SSH. I started by defining the connection model, a class called LG connection model that holds the username, IP address, port, password, and number of screen. This model also know how to save and load it from shared preference. Then I described the core service LG service, which is implemented as a strict singleton. Why a singleton? Because we should have only ever have one connection to Liquid Galaxy at a time. This avoid conflict, duplicate connection, and resource leak. The skill also teaches the AI three very important things. First, SFTP upload. Instead of just sending the raw SSH command, we used KML files saved to LG web server as at uh, slash var slash www slash html slash. Second, the random file names. We every time we upload a kml file, we append a timestamp to that file, like weather1234.kml. This this is the thing. Yes, it is here. This is critical because it bypasses the browser cache on the Liquid Galaxy. Without this, Liquid Galaxy would keep showing the old data. Third, the force refresh after uploading. We use sed to inject mode tag into the master camel file, which tells all Liquid Galaxy screen to reload immediately. This skill also cover logo management and how to cleanly disconnect. When the AI reads the skills, it will never write incorrect Liquid Galaxy connection code. It know exactly what to do. The next skill that we will discuss is KML generation.md file. The second skill is this. KML stands for Key Hole Markup Language. It is the format that Google Earth and Liquid Galaxy use to display visual data. Markers, path, polygons, overlays. This skill is extremely important because KML has specific rules that are easy to get wrong. Especially coordinates in KML's coordinates are written as longitude first, then latitude, the opposite of most people expect. If you swap these, your data appears in wrong place on the globe. This skill teaches AI a KML builder class. You can see here. Yes, the KML builder class, a clean, reusable builder pattern that can create place marker, which simple location marker, path, line connecting multiple points, polygons, which are filled areas. It also cover advanced features like animated tools using gx semicolon tour, which LG automatically files between locations, and styled balloon with HTML content. We have this style marker, multiple flight path, have area coverage, and animated tour balloon, and there are also color system. KML use a specific colors format called AABBGGRR, which is alpha, blue, green, red, the reverse of normal RGB. The skill teaches the AI this format and provide a helper class called KML colors with predefined colors. Finally, the skills show exactly how to send the KML to Liquid Galaxy. This thing, the sending to Liquid Galaxy. uh, write where www.html kml slash 2.kml and trigger fly to command by temp query.txt, and we have some here best practices. This means whatever someone asks to AI to display anything on Liquid Galaxy, it will always generate valid correct KML. This is the all about the camel generation.md file. Next, we come to this API integration.md skills. This is very important as we use an external API in this. So let's start the API integration skill. This is the important third skill. uh, every good Liquid Galaxy app fetches data. Generally, Liquid Galaxy app fetches data from the real world. This skill teaches how AI to do that correctly, that thing correctly. At the core, base API service class. Yes, this implementation, uh, base API service class, any API service in the app extends the base class. It handles get and post request, URL construction with query parameter, and most important, response handling. The response handler check status code properly, 200 range success, 404 resource not found, 401 unauthorized check API key, 500 range server error. The skill also include a complete weather API service. This thing, example using open weather map, include a weather data model with a 2 kml method. We have this 2 kml method. This is beautiful because it means the data model itself know how to convert kml, connecting the API layer directly to the visualization layer. Other important pattern in the skill include rate limiting, so we do not exceed API quota, and implementing timeout so the app never hangs. For my demo app, I used uh, this weather current open weather map 2.5 API, which provide the weather of different places. This API is perfectly fit for Liquid Galaxy because it is the basic API that we can use in app for fetching the weather data. So this is all about this API integration.md skill. Next we come to Flutter UI.md skill. We have the fourth skill, Flutter UI.md. The skill is visual layer. It teaches the AI how to build beautiful, consistent UI for Liquid Galaxy apps. It start with the standard screen template. Every screen in our app follows the same structure: stateful widget, init state for initialization, dispose for cleanup, a build method that separate loading state from content. This skill defines several reusable widgets, specifically for Liquid Galaxy app. LG connection status widget. This where Yes, this LG connection status widget, a pill-shaped indicator, that show green when the connected and red when disconnected. It always visible in app bar, so the user always know the connection status. The data card widget, this data card widget, a clean card component for displaying any kind of data with an icon, title, and value. This is used throughout the demo app. The loading overlay, a semi-transparent overlay that block user interaction during a sync operation. This prevents the user from tapping button with while data is being sent to LG. The skill also cover navigation pattern, both raw navigation and tab navigation, setting screen with the text field and switches from validation, and the theming with both light and dark mode. This is all the Flutter UI development skill. uh, the complete Flutter UI skills to make the app from basic to the usable purpose. Next, we have the last skill, state management.md. This is the fifth and final skill. State management is one of the most important and often misunderstood aspects of Flutter development. The skill gives the AI a clear, simple approach. We use provider package for it is lightweight, well documented, and perfect for app of this scale. The skill defines two keys: the connection provider and the which wraps the LG service. It exposes three states: values, is connected, is connecting, and error. Any widget in the app can watch these value and rebuild automatically when they change. Second is setting provider, which may manage user preference like IP address, port, username, and password. It persists these settings using set preference so they survive app restart. The app architecture pattern is clean and follow solid principles. The service handles all logic, SSH, API, and API calls. Um, the provider wraps the service and exposes the state to the UI. The UI just consumes the provider. It does not know about SSH or HTTP. This separation means each layer has one job and one job only. This is exactly the single responsibility principle from the solid. And the skill also teach how to use consumer T perfectly for rebuilding only part of the UI, and context.read T for one-time action like button press. With these five skills together, the app has a complete understanding of how to building an Liquid Galaxy Flutter app correctly, I think. So this is all the skills, and we have also gone through the lib folder. Let's go to the app demonstration that we have made by using this AI dot agent folder by the Antigravity. Now uh, uh, now let me show you the app that was built using this agentic system. The app is Flutter is a weather app that fetches the data from Open Weather API and show it on the Liquid Galaxy with using balloons. So this is the Android Studio where I have opened this. These are the lib, and we have these folders. This is main, and this is all normal. We also, you can see, this is pub spec. And now let's come to the, I have run the app. Here you can see our app has run correctly. These are the weather in major cities. Here it is shown offline, it is the setting, it is connect button, it is clean, and it is logo button. We can reload this thing from here. It is getting reload. These are the data. As you can see, we are now clicking here. It is showing connect to LG first. That means it is not connected. As you can see here, offline is already also written. We go to this setting, and we have written my LG rig connection details, then save configurations. As a configuration is saved, now we will run the connect command. So from here, as I connected, this clean and logo button enables, and here you can see this is connected, means now our LG rig is connected to my this app. Let me make it clear. Yes, so first we send the logo. On clicking this, a logo must be sent there in leftmost screen, and you can see the logo is sent perfectly. On clicking clean, it get clean from the screen. So if we have to see this function, if we click on Tokyo, it go to the city here Tokyo, and you can see it is, it takes some time to render or refresh. Yes, on clicking this, we can show the Tokyo and Japan, its temperature, its humidity, its wind, pressure, and the direction of the wind. These are data that we can see perfectly. As you can see, it is synced properly also. Try another city. Let's try New York. It go to New York's and you can see by clicking here we can see the data 2.2 degree, very cold, and humidity, wind speed, and pressure. Let's go to next city, Sydney. We can see the temperature of Sydney as well. Yes, perfectly working. Now this is the complete demonstration of app. You can see the app and the logo working. We connect to disconnect button. Clean is working. We clean, the camel is also clean. So app is working good. As app contains all the feature that is asked in the task, to that logo clean and that logo thing and cleaning thing and the camel sending things. So it is all my app. Let me complete the video by summarizing the and concluding the things what I built in this contest. Repository 1, the Gemini Summer of Code, contains a complete Flutter template and 5 careful crafted agent skills file that teach AI how to build a Liquid Galaxy application correctly. The second repository that I have shown contains the demo app that I have made using this agentic system. I believe that this system will help you for future GSoC contributors get started with Liquid Galaxy development much faster instead of spending weeks learning the connection pattern, the KML format, and the architecture. They can start from this starter kit and have the AI guide them from day one. Thank you, Liquid Galaxy mentors, for this incredible contest, and I hope that it will help the future contributors to start with Liquid Galaxy's apps. And that's all from my side. Thank you for your time.
So hello Liquid Galaxy, this is Anirudh Pratap Singh Yadav, a second year AI student from India. So this video is my submission for the Google Gemini Summer of Code 2026 powered by Liquid Galaxy. So in this video I'll be showing you the GeoVisual app, which is like the earthquake dashboard system made by Liquid Galaxy, Flutter and Antigravity specifically. I've also added a splash screen, like if you play games, right, there's an animation, there's a intro before that which requires a high GPU. So I tried adding like AI voice in that, and it's quite a video made by Nano Banana Pro model, and it's like a splash screen. So it might not work here, but I'll be adding the clip just in case if it stutters a bit, right? So let's get started with it. So let me fix my screen first. Yeah. So okay, so this is my app, this is my setup. LG1 is the master, LG2 and 3 are the two slaves. So let it just load, and yeah, so it loads fine. Okay, yeah, this is a splash screen, but yeah, as you saw, it lagged. But as you can see, like it is lagging because of, like, I wanted to be transferred, like my recording machine has like 8 GB of RAM and an integrated GPU, so which struggles to run the Flutter, right, Flutter rendering and OBS Studio and Android Studio, everything, right. And so engine and high bitrate screen recording is simultaneously. Okay, so to prevent this from affecting the actual Liquid Galaxy setup cluster, I implemented an isolate based processing for the KML generation. As you can see here, like it offloads the heavy string manipulation by and payloads of SSH, and we just take it to the main, I have ensured that the main thread, the one which is responsible for all the live feed of the data and the SSH connection, is in the other thing, and the actual commands are kept in one screen. So the UI frame rate somehow gets detected, but my splash screen and the whole app might work in the good GPU system, and especially where in La Isla, Spain, where Liquid Galaxy has their official lab with the high GPUs, right? So let's get started with the app. This is a connection thing. So I'll enter offline mode and just So I'll just fix my IP, which is 192.16.5. Okay, 56.101. Okay, save and uplink. Yeah, it's worked, right? And the logo logo also came. So logo also came, it worked. So as you can see, this is my IP, this is my username, password, SSH port, number of disks. This is dark mode and light mode, and this is my about section, which is GeoVigil dashboard, official submission for Gemini Summer of Code 2026 by Liquid Galaxy. So these are all the main buttons, which is reboot, relaunch, shutdown, and clean KML, and logo. So this is mission control. This, as you can see, SSH uplink is green, data streams is blue, which shows that it is connected. And let me see if let me initiate a cinematic tour first. So
GeoVigil alert. Initializing Liquid Galaxy protocol. Establishing secure SSH tunnel. Tectonic synchronization complete. System ready for deployment.
so because of extreme GPU connections, so it doesn't matter. Yeah, so it loaded, right? These are all the data streams I'm getting in live flow. These are the data streams flow I'm getting using the API, so live API. So let's do initiate cinematic tour first. You'll notice something in LG2 here, right here. It will be about the earthquake, what specifically which earthquake came, and at which place, everything which will be coming here. So yeah, so this is the KML which is loading. It's going right. It's going. Yeah. It should go. It should. Yeah, it moved. So yeah, it worked, right? It worked. So as you can see, it loads into the data. Now let me do just this one. See, as you can see, the data has come. Like depth is 10 kilometer, magnitude is 5.2, and LOC is Central Mid Atlantic Ridge, somewhere in there at that place. Let me see of the Russia one. So these are all live from the live API, earthquake API, and I've called it through data streams. And see, it's about came, magnitude is 4.9, and depth is 61.302 kilometer, 186 kilometer SSW, and everything, right? So let me just try one more time. Yeah, so it worked, right? So it basically, I just actually wanted some tectonic plates movement, the LG connection, like the whole land, but I was not able to do it because I don't have the proper guidance of that. But hopefully, if I get selected under a mentor's guidance, I will be able to proceed with the tectonic plates and the 3D movement, those polygons being the 3D covering whole area. I just want to have an idea with of floods and all. So just to prevent, this is a simple dashboard, but we can just make it more better and more enhanced. So let's move on to the code now. I mean, code is must, right? So let's move on to the code, right? So the agent skills. Let's talk about the agent in GeoVigil. So this is I gave it's a system built using agentic programming, and it's not not just a UI. And I developed this is a KML generator. I developed that tells KML master skill, which tells how how to handle liquid galaxy specific tags like GX, duration, central, and explains everything about liquid galaxy system, like left rig, right rig, and the center rig, which is the master, and how to do it, the KMLs, how to send the data, KML visualization standards, 3D extrusion, cinematic camera. I just explained everything and just put on a prompt to the T2 agent, which is Gemini 3 Pro, and I have explained everything. This is a whole concept behind the liquid galaxy, and then just prompt just to make it better. And SSH connection just explain like what it needs, which package it needs, socket exception, try catch, it's must like for the exceptional handling, and everything which is required. So if you see anything like let's now move on to the screens part. And first of all, if you're doing agentic programming, your agent skills are must. The more better you explain to the agents, the more better output you get, and in very less time. If I talk about this app, I got this app in like 40 minutes, but when I added the splash screen and the voice, it took me some time, like it took hours to fix that because of laggy screen. So it was actually suggested by Antigravity only to add like a connection between SSH and like the splash screen, so it doesn't get laggy, but somehow it's laggy in this device. So let's talk about the connection page now. Connection page is the simple connection page of like it follows the Dart, and there's a widget build, like I build the widgets. And if I talk, this is normally the connection which is happening. So like we just connects, like it also tells you the state, like if it is connected or it is connecting or it's connected, like if you saw the red green thing, right? So it's the connection page now. Yeah, so this is the splash screen. The splash screen is actually the video which was playing. Okay, let me show you the video first. So this splash screen is actually this video. So this splash screen is actually this video which was playing, and also I had added the sound. Like if I could show you my pub spec YML, yeah, so it's here. So as you can see, assets is my intro, and my flutter lints is my that sound which I have added, video player, shade preferences, everything is there, right? But it didn't work out in this video, but I will add a clip to it. So let's move on to the home screen data. So this home screen dart is actually like having all the buttons which is must, like liquid galaxy, so, like tour KML and all the things, like mission control, which showed the mission control, which like every button which is having, right? So this is a settings page, which is a separate page. Home screen is this page, the first page where all the live data came, and this is the settings page where everything is there, right? So I've used the liquid gases logic behind every button which is in settings page. It might be reboot, shutdown, or restart, or I've also used the refresh mechanism. So see, these are the like earthquake sensors. So this is USGS government like earthquakes feed, live feed, which is coming up from the API. Okay, and like this is the LG service dart, which is like for scaling a project like this, which requires a clean code, right? So I followed some solid principles, like single responsibilities, like the LG service only handles SSH communication and it doesn't know where the data comes from, and I can swap the like USGS API for a local test data set without changing a single line of UI code through Antigravity. And if you see my all the logic, so like if you see my send to slave logic, so it is actually telling which screen to send, like logo is to be specifically sent to LG3. These are the KMLs, and like the about section is to specifically send to LG2, because if you send it to LG1, it should not work, right? And this is the fly to view, and these are the LG reboot, LG async function, and relaunch function, shutdown function, and this is to override the blank KML. If it is not connected, you should override the blank KML and override slaves with blank KML, right? So these are the everything. Like, it should contain your exceptions as well. Your code should contain exceptions as well, and um, not only your data what you wanted, but exceptions as well, to just in case something happens, right? You should add something else as well. So this is it. I'll be adding the clip of the splash. I hopefully, like, unfortunately it didn't work, but hopefully you'll be able to see in your system when you take my code from GitHub. And I've also added license just in case. I'll just mention it. I've added readme files as well and the license as well. So this is my license and the MID license, and this is the readme. So I've added a whole code in the GitHub, and I'll be sharing a GitHub link with the community. And okay then, thank you for listening to me, and thank you for your time. Thank you.
Hello everyone, my name is Bhumi Shivhare and I am a third year BTech CSE student, and today I am presenting my submission for the Gemini Summer of Code agentic programming contest. The Liquid Galaxy project offers an incredible canvas for developers, but getting started can be a massive hurdle. So managing SSH connections and passing KML data without crashing the UI requires a lot of boilerplate code. So my goal for this contest was simple, like remove that friction entirely. So I wanted to build a Flutter starter kit that handles all the heavy lifting, like the networking, the state management, the threading, so that the next developer can just sit down and relax and plug in their own ideas and start building. So I designed this kit with a strict philosophy. We go slow and steady, ensuring maximum reliability without ever jumping into an unpredictable error state. So instead of showing you a fleshy UI right away, I want to take you under the hood, right? So under that, because the true value of this submission isn't a single app, it's the engine that powers it. So let's look at how this kit is structured for stability. Okay, so now let's look at the heart of the submission, the starter kit itself. So when you start building for Liquid Galaxy, the biggest trap developers fall into is putting all their SSH logic, state management and UI into one massive messy file. So it becomes impossible to maintain. And to solve this, I built the starter kit using a highly modular architecture called MVC, Model View Controller. So yeah, like you'll feel right at home here. I've adapted that philosophy into a modern Flutter architecture using the block pattern. So here's how we can separate our concerns. Okay, so our views, the UI pages are completely dumb. Like they don't know anything about SSH clients or IP addresses. They just send events to our controllers, which in this case are our blocks. So this is my library folder, and first we have the core folder. Think of this as the global toolkit for the entire app. Like this is where the heavy lifting happens. So inside my services folder, we have SSH service, setting service. This is the powerhouse of the kit. Like it handles every single task to requirement out of the box, and it doesn't just open a connection. It contains dedicated pre-configured methods to clear the rig, reboot the clusters, and securely manage the Dart SSH2 session. And inside the utils, we have our KML generator .dart. So instead of hard coding XML strings everywhere, this utility acts as a safe translator, taking our dynamic coordinates and converting them into a perfect Google Earth XML without freezing the app. And in the failures, we have lgexceptions.dart, okay, which catches my SSH timeouts or connection drops gracefully, ensuring we never jump into an unpredictable error state. Okay, so I'll just, yeah. So now let's move to the features folder inside the library folder. So this is where our MVC architecture really shines. So I'll just expand it. Yeah, so every main feature like connecting to the rig or controlling the dashboard is strictly isolated. So we have our data repositories. They act as our models, like setting the strict rules for how data moves back and forth to the Liquid Galaxy rig. Okay, so now we have our presentation block. It is here, and these are our controllers. Like, they handle all the business logic on the background thread. When a user clicks orbit, the block processes it securely. And finally, we have our pages. Under the presentation folder, we have our pages, and these are our views. They are completely dumb. They don't know anything about IP address or SSH protocols. They just display the UI and send user tabs to the block. So by handling KML generation in a dedicated utility, we keep our main thread clean. We process the data, wrap it perfectly, and then stream it over to the rig. Okay, so now let's talk about the agentic part of this contest. So when you're building for Liquid Galaxy, the biggest problem is that you write a bad piece of code, send an SSH command, and the whole rig freezes. So my goal with this agent folder is, so my goal with this agent folder was to build tools that physically stop developers from writing bad code. So inside this folder, I have this rule book, and the main rule is architect.md. So it is very simple. It just tells the agent that we go slowly, steady, and we avoid error state at all costs. Okay, but the real core of the submission is right here, the skills folder. Okay, so the structure of the skill and agent workflow was inspired by Mentor Victor's approach, and which provided a clear and practical foundation, and I adapted his idea to fit my own starter kit design and development flow. So, okay, if you ask one AI to do everything, it gets confused and gives you bad code. So I broke Gemini down into 10 distinct single-purpose skills. So it's basically a team of 10 specialized developers living inside my code base. And I built a strict 6-stage AI pipeline directly into the agent folder. Okay, so let me walk you through the workflow now. And it all starts with like LG init. LG init. Okay, if someone downloads my kit, this agent acts as the chief architect. It interviews the user about their rig setup, project overview, and also like their IP address and how many screens they have, and sets up the core folder structure. Okay, so now once the app is initialized, we don't just start coding. We move to the phase 2, that is LG Brainstormer. Okay, so this agent forces a developer to think about the physical reality of Liquid Galaxy. It makes sure we aren't just building flat apps, but actually designing sweeping, dynamic orbits like that looks good across multiple screens. And after we agree on that idea, we move to LG Plan Writer. Yeah, so it breaks the idea down into strict step-by-step markdown checklist. It plans the UI, the block state, and the SSH commands separately so things stay organized. And only then we do reach our phase 4, that is LG execution. And this is the execution engine. It actually writes the Flutter code, but it does it slowly, strictly following the plan, so we never hit an error state. And once the code is written, we move to the phase 5, that is LG Code Reviewer. Yes, so it acts as our QA tester. It forces a developer to run Flutter Analyze and Flutter Test, and it physically won't approve the feature until the code is completely clean and memory leak free. And finally, my favorite part, phase 6, Liquid Galaxy Quizmaster. Okay, so once a feature is working on the screens, this agent acts like a game show host. It quizzes the developer on the code they just wrote to make sure they actually learned the architecture and didn't just blindly copy pasted everything. Okay, so now you might be wondering, what happens if a developer tries to cheat this pipeline? What if they tell the AI to skip the planning phase and just write the code? So that's why I built the LG Skeptical Mentor. Okay, so this is the emergency brake of the entire system. If a student tries to cut corners, this agent automatically steps in, halts the pipeline, and gives the student a pop quiz on clean architecture before letting them continue. So it physically protects the code base from bad habits. Okay. Lastly, alongside that core pipeline, I built 3 specialized utility agents. The LG rig controller. So what it does is it automatically generates all the complex SSH commands needed to reboot, clear, or manage the Liquid Galaxy hardware. And the Nano Banana Sprite. Okay, so this file helps format AI generated images. It removes green screen background so we can send perfect transparent PNGs over to Google Earth. And my LG Gemini voice navigator, and it helps me integrate voice controls so user can just speak into the tablet to fly around the globe. Okay, so by forcing the AI to work in this exact sequence, like init, brainstorm, then plan, then execute, then review, and then quiz. So we take all the guesswork out of the Liquid Galaxy development, and it guarantees that the code is slow, steady, but rock solid. And okay, so now I do want to apologize in advance that the demo app I am showing today is quite simple. Being right in the middle of my university exams, I was really short on time, and because of that, the demo app I'm about to show you is kept intentionally simple. So I chose to focus 100% of my time on making the underlying starter kit absolutely rock solid. So the demo is lightweight, but the architecture beneath it is fully equipped to handle incredibly complex, polished Liquid Galaxy experiences. Okay, so the anti-gravity task view reflects this workflow in action, showing each phase and task completed step by step from initialization to final validation, ensuring clarity, traceability, and disciplined execution through development. So that's the project in action. Okay, so looking back at this whole contest, building this starter kit was honestly one of the hardest but most rewarding engineering challenges I've taken on, and especially trying to balance the workload. And I genuinely hope this kit and the AI team living inside it helps the next wave of students build incredible things without having to spend weeks debugging SSH connections or memory leaks. So, thank you to the Liquid Galaxy team and the mentors for the opportunity to build this. And I really appreciate your time today. Thank you.
primary screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid Galaxy, we see it all. Technological marvel.